All right, good morning, everyone. I am alone in my lab, so I'm gonna go ahead and take off my mask. It's good to be safe. My name is Ashley Sloan, and I am the lead instructor for the Qualcomm Thinkabit lab in the Virginia Tech Roanoke Center. And today I'm gonna show you a little bit of beginner engineering and beginner coding. So the first thing we're gonna do is I'm actually gonna show you a bit of the pieces that we use here in the lab to help program some circuits. And these are some fun circuits. We can do some really cool things with them. So I'm going to show you all the pieces, what they do, and then we're going to actually build a circuit, make it work, and then we're going to code something for it. And I'm going to need your help later on to tell me how we're coding it. All right. Now, first thing I'm going to do here is I'm going to show you the pieces that we are using. So I'm going to switch to my document camera. Give it just a second. There we go. All right. Now, let's see. It's actually a little bit better without the light, I think, for you all. So this first really cool piece that you can see here is my Arduino. Now your Arduino is actually a small circuit board here. So on this teensy tiny little circuit board, it actually has a microcontroller, which means it can program certain things to happen, right? We can program it to do things. So the first thing I want you to notice on this Arduino here is this big silver box. So this big silver box is actually where we're going to connect our power. You can see here that there's a little outlet for our power cord to go and plug in there. And then I want you to take note of these two rails along the side. Now, each of these rails has a very important purpose. So this short one here, we actually call, let me get my camera centered. There we go. We call this one the power rail. And on this rail, you're going to find some really important things, like two ports labeled G and D. Now, I know that sounds a little weird, but what if I told you it meant ground? Has anyone ever heard of ground when it comes to electricity before? So I want you guys to think about, like a lightning rod when we have electricity. Does that lightning just hit the rod and go, just into the building? Do we have it go into batteries, which would be really cool, right? Or does it go from a wire all the way down the side of the building and into the ground through a steel rod? It's the ground, because we have to disperse that electricity safely. So that's what our ground prong does here, is it disperses our electricity safely. Now, we also have a few other really fun ones here. We have 5V and 3.3V. Now that V stands for volts, and that's the power that we're going to use, power rail, to power our circuit. Now on the opposite side, this long rail is our digital rail. And here you can see a series of numbers, right? Now, some of those numbers are a little bit different than other ones, right? Some are just a flat number, and then other ones have a squiggly line next to them. Now that squiggly line tells us that it is a PWM. Now that PWM stands for pulse width modification. I know it's a big, scary term, but what that actually means is that it's alternating power and signal at the same time. So it can program and it can send power. And that's going to be really important for us later. All right. Now, the next piece I want you guys to take a look at here is our breadboard. Now, this mini breadboard has a series of ports along the side, right? And then they're divided in the middle. So you can see here, I have 5 small ports on each side here, but there's a bridge in the middle. So my 5 red ones over here are all connected to each other, and my 5 black ones over here are all connected to each other, but they actually do not connect to the red to the black, right? Unless I use something to spark a connection, right? And when we work with electricity and we need to spark a connection, what do? We use wires. So I can use wires to connect each of these points. But as it stands by themselves, the red are connected to each other and the black are connected to each other, but they are not interconnected. All right, now, since I brought up our wires, I will move to that next. Now, on the inside of these wires is a metal, right? Like copper. It can be other kinds, sometimes iron, I think. And what this does is it is a conductor, right? So that metal conducts the electricity, it shoots it through the wire, But then this rubber on the outside is an insulator. It actually protects us from getting shocked. And we can also use this insulator part, this rubber, to give us different colors, right? Now, these wires are fundamentally made up of the same materials, right? They're all rubber and they're all metal. But with the different color, I can give them each different tasks. And I can assign each wire a different task to complete, a different job to do. And that way I know what wire is doing what. My next piece here is a resistor. Now, what a resistor does is to resist is to pull back, right? To hold something back. So it's resisting some of the electricity. So for our circuit today, we're going to be using the 5-volt pin on our power rail. But what if I told you that our LED only operates at 3 volts, and if we put 5 volts through it, we could blow the LED. Now, we don't want to make explosions today, right? It's never fun. Plus, it's not really that flashy of an explosion. Just kind of goes out. So instead, we're going to use a resistor to hold back some of that electricity and make sure that our LED can work without a hitch. Now, to look at our LED, are both of the legs the same length? They're not, right? One's a little tiny bit longer. And that actually makes a difference with our LED because our resistor, unlike our LED, you could put either leg, either direction, and it won't matter. You can go either way. But with our LED, we have to make sure that we are going in a specific direction because just like a battery, it has a positive and a negative side. And that long leg there is our positive leg, and that short leg is our negative leg. And that's going to be really important for building our circuit. All right, and the last piece is our power cable here. It is a USB-A to USB-B. It's pretty simple there. So now we're going to get started connecting all of our pieces. So I'm going to zoom in a little bit for you. There we go. All right. Now, the first thing we're going to do is we are going to take our grounding wire. For that one, I always use the black wire because I think ground, black, like dirt, So we've got our grounding wire here. And we're going to go from one of the two, if you notice there are 2 ground pins on our power rail. I'm going to go into one of those and then connect that over just like the black color of my wire to my black row on my breadboard, just like that. And that's my first connection. Next, I'm going to move to my power. And for that, I'm going to use the red wire. So I think electricity is hot, right? You call it a hot wire if there's electricity pumping through it. So red, hot. Red is our power wire. And we're going to take that one from 5V, like I said earlier. I'm just going to make sure that I'm getting the right pin there. Yep. And I'm going to go all the way here over to match my wire to my red row there. Right? It's a little bit matching here. And then I'm going to take my white wire. Now we call this one the control wire. And we use this one to help us program. So this control wire is the only one that's going to go on our digital rail here. And we actually need pin number 13. And I'm just going to make sure that one's in pin number 13. And then we're going to go over to our blue row and connect it over there. All right. Next, we want our resistor. So our resistor is going to be bridging the gap between our LED and our power. So we're going to go from the red row where we have our power to the blue row where we're going to be programming our LED, right? Now, because our breadboard is so cool in how it's connected, it doesn't matter which pin I put these in as long as they're in the correct row. So they could be in any of the 5 pins here in the red row, but as long as it's in the red row where I need it, it's absolutely fine. All right, next I'm going to take my LED. And I want to make sure I know which leg is my long leg, right? So I'm going to take that long leg, that positive leg, and that's going to go in the blue row. And my short negative leg is going to go in the black row, just like that. Now, my circuit is all hooked up, but did it turn on? It didn't because I don't have any power going to it yet. It's always good to connect your circuit before you put in the power, just to make sure you're not going to accidentally fry anything. And there we go. My circuit is on and it's actually already blinking, right? Now, the next thing we're going to do is we are going to switch to programming. So we've got our circuit now. It is on, it is blinking. It's got electricity running through it, right? So now we need to give it some jobs to do. We need to tell it how it's gonna blink. So to do that, we are going to go into the Arduino software here. And this software is really cool. It really helps you with building circuits and creating some really interesting things. Now, does this look like code to anybody? It's kind of, you know, some paragraphs here, some dates going on, some titles happening. Yeah, it's not really code, but if you scroll down, you'll see here at the bottom, we've got a lot of code here. Now, this is a pre-built code for us. So I didn't have to do anything to this code. It just came built in, right? It's a basics. It shows you how to do it, but we're going to change it. So the first thing we need to change is we need to tell it where we plugged in our circuit. Now, does anyone remember where we plugged in that white wire on our Arduino board? Was it in pin number 97 or 316? No, how about 13? So we're going to take anywhere the LED built-in is, and we're going to tell it, hey, we plugged that in pin number 13. So I'm just going to change anywhere in my code that says LED built-in to 13. And that's the first thing we have to do to alter our code for what our purposes are. Just like that. Now, the next thing we want to do is we want to change our pacing. So that's how fast our circuit is blinking. So right now, I'm going to show you guys, as soon as it loads, it's blinking once every 1,000 milliseconds. So it's on for 1,000 milliseconds and off for 1,000 milliseconds. Now, does anyone have a guess on how long of a time period that 1,000 milliseconds might be? I'm going to give you guys a second to think about it. It's 1 second. If you got it right, give yourself a pat on the back. If you didn't, you learned something new. Now, that 1,000 milliseconds is 1 second. So what I have it doing now is on for a second, off for a second, right? And that's fun, but it's a little boring for our purposes today, isn't it? We want to do something interesting. So we're going to change up how we have that programmed. And I'm going to get my friend in the lab to shout out some different variations for me to add to this so we can get some really crazy looking, some blinking happening here. All right, so lab assistant. Every 3 seconds. Every 3 seconds. All right, so we are going to alternate. So now instead of having this here where it says digital write 13 high, that's when it's on, right? So high is on, delay 1,000. So it's telling it to be on for 1,000 seconds. And we're going to make it 1,000 milliseconds. So we're going to make it 3,000 milliseconds to make it 3 seconds. And then we're going to do digital write 13 low. That's when it's off. The same thing. It says 1,000 milliseconds. We're going to make it 3,000. And now I'm going to go up to the top here, and I'm going to upload my code to see that change. And as that's happening, switch my camera here. Oh, it might help if I declared my port. Silly me. There we go. And now it is on for 3 seconds and off for 3 seconds. See that? So now that seems like a really long time, right? Do you want to try something a little bit crazier? What about a half a second? What? So let's see what a half a second looks like. So if 1,000 was 1 whole second, right? I'm going to want to do half of that. So 500. And I'm just going to replace those same values that I changed before, that 1,000 to 3,000 and that down on both sides, and make those 500. I'm going to upload it again. And as I do, it'll blink to show me it changed. And now it's blinking faster. Now, I might hear you asking to yourself, maybe it's just me, but how fast can we make it go? That is a great question. So, how fast could we make it go and still be able to see it? This is a question I've had a lot of my students ask me, and it's actually very fun to answer. So, when we start this, we're operating in milliseconds. And your brain can only catch a certain amount of movement in each second, right? In each millisecond. Which is why if you think of playing video games, maybe, you might hear 60 frames per second. That's how many frames are moving on your eyes before it can catch. Now for this, let's see, I'll show you, I think, let's do 30 milliseconds first and see what that looks like. I'll show you how fast that is. It's very fast. But it's still an amount we can see. So if we change it to 30 milliseconds, and warning for anyone who is sensitive to flashing lights, by the way, just giving you a heads up here. Now we have a very quickly blinking light. There it is. Oh, and the camera almost can't catch it. Kind of looks like it's wavering a little bit, right? So for us, it's actually blinking really, really fast. Now, if I put that number, instead of being 30, if I put that down to 10, it's just going to look like it's staying on completely. So right now you can see how it kind of is dimming a little bit, right? It's kind of fluctuating. Well, if I change this number to 10 instead of 30, all you're going to see is just an on light. It's not at all going to look like, and there's the upload. And now it looks steady to me. Actually, you can still see a waver on the camera, which is really cool. So you can see that it is varying. It's a lot harder to see in person because right here, I'm looking at it and it just looks like it's completely on. But something that is really fun to do is if you program an LED to move really fast and you want to make sure that it's actually changing and you want to see what's happening, you can always open your camera and find the slow motion option. So if I go into my camera and I go into, let's see, where's my super slow-mo option? My camera might have changed, but if you find your slow-mo option on your phone, you can actually hover over the light and you can see on your phone's camera that variation, that it's moving instead of it just looking like it's going straight on. All right. So that is our fun with LEDs today. And next, we are going to move on to fun with servos. So I'm going to show you how to connect a little more complex servo, a more complex circuit, excuse me, and then I'm going to show you how to program it to move. All right, so now the first thing to do is to safely disconnect the circuit we have going now. So the first thing I want you to do is I'm going to, and you can watch me, unplug this in reverse order. So I'm going to start with my power cable again. I'm going to disconnect that. So I make sure all my pieces are safely unpowered so I can't shock myself. And then I'm just going to unplug things in the exact reverse order that I plugged it in. So the last thing I plugged in was my LED aside from the power cable, right? So take that out, then my resistor, and then my wires, first from the breadboard and then the Arduino. And then next the red wire from the breadboard and then the Arduino. And lastly, our grounding wire. You always want to end with your grounding wire to be as safe as possible. All right, and there's all my pieces again. So next, I just need a servo. Now, servos are really cool. These are small motors that you can program to move to specific motion. So this right now is a continuous servo, this big one here. And so this can move in a complete 360 degrees. So it can move in a full circle. So we're going to plug this one in. Now, if you notice, our wires here are red, black, and white, just like the wires we used before. And we're actually just going to, our first step is to take this black box at the end, and we're going to connect our wires to it. So white to white, red to red, black to black. What did I say we always start with? Our black. So first, take your black wire and connect it there. And then your red. And lastly, your white. And now we have this funky looking spider thing, right? I know spiders have 8 legs, so technically it's an insect, but it still looks like a funky looking spider thing. And now we're going to plug this into our Arduino. So again, we're always going to start with that grounding wire, and we're going to plug that grounding wire into one of the 2 ports labeled ground on our power board. Then we're going to plug in our power, and we're going to go with the VIN. That one's right beneath our ground. So that actually stands for voltage input. And we're going to plug that one in there. And last but not least, our white wire is going to go way over here in pin number 9. Now, if you take a look at my board, you're going to see, so 13, if I can get it to angle correctly, maybe, oh, there we go, kind of. All right. So we have numbers from 13 down to 1. 13 was what we used for our LED, and that one does not have that squiggly line that tells us that it is a PWM, that pulse width modification, but 9 is. So for 9, what that means is it's going to be able to send signal and power at the same time. So next, we're going to give it power, right? We've got all our wires connected. So we're going to plug it in. And then we're going to open up Arduino, and we're going to start from here. So first thing I need to do is tell it where my Arduino is, which was where I had that problem earlier. Oh, that's strange. There we go. That was weird. It would not let me click. All right, so my Arduino is already declared. We're good there. So next, I'm going to go over here, and I'm going to tell it that I need Sketch here, and I need to include the library for our servo. So I need to find here. Aha, there it is, hiding my servo library. Now, up at the top, you'll see my code has changed, and I've got include servo.h. Now, what that means is that I have now told it that I'm talking to a servo. So I needed the correct dictionary to know to talk to that servo. So like, think about if you're going on a trip to France. If I'm going to France, would I want a French to English dictionary or a German to English dictionary, right? I would want a French to English. So you need to have the correct dictionary for what you're talking to. And we're talking to a servo. So we just told it that we are. And then I need to name my servo. So I'm going to come over here, and I'm going to declare that this servo that I have plugged in is called my servo. And with every line of our code, we have to end with a semicolon. That's what tells the computer as it's reading it, hey, that's that end of the line of the code. So we told that our servo was called my servo. And now we need to tell it where we attached our servo in this void setup section. So in this part, I'm going to put my servo, which is the name of my servo, dot attach 9, because that's where I connected my servo. And then I'm going to go down to void loop. Now, a loop, especially when we talk about code, means it's just going to keep going, right? It's going to keep doing it over and over and over again. It's looping that function, right? So for the loop section, I'm going to tell it, I'm going to tell it to go as far as it can to the left first. Let's do 2 seconds. And just like when we did our LED, we're going to use delay, and then we're going to tell it a number in milliseconds. So I told it for 2,000 milliseconds, that's 2 seconds. And then we're going to do my servo.right again. But this time I'm going to tell it to go as fast as it can to the right, which is 180, for another 2,000. And then I'm going to upload to show you what this is going to do. whenever my camera decides to. There it goes. We got some lag, people. I'm sorry. Oh, my servo's stuck though. There it goes. All right, so now that is moving to the left for 2 seconds and then to the right for 2 seconds. But I can change this up. So just like with our blink, I can alter my code to make it do different things. Now, one interesting thing with this continuous servo is that it works kind of, picture a number line, right? Now, if 0 is the start of my line, and that is as fast as it can go to the left, 180 is the other end of my line, that's as fast as it can go to the right. In the middle, I have 90, and that's stop. So any number between 0 and 89 is telling it to go to the left in varying speeds, and any number between 91 and 180 is telling it to go to the left, to the right in varying speeds. So with this, we can actually program it to do a wide range of things and make it stop and start in interesting ways and go at different speeds. So let's see, lab tech, what should we start with for our first speed?
120.
120, all right, so we're gonna go with 120 first. And we will do that for 1 second. Which would be 1,000 again. All right, and then what's our second speed? We should probably go, let's see, go to the left this time. So anything between 65, I like it. All right, now, we're gonna do that one for another 1,000. Okay. Now I'm going to tell it to upload. And so those are actually about the same variation, but if you notice, it is slower than it was before. We had some really great middle numbers, so we've got a good mid speed here. And you see it's moving a little bit faster than it was before too, switching between the two because we shortened that time period. All right. Now, what if we did, so one thing that I find really interesting with these servos is even though 90 is supposed to be stop, for some reason with some of these servos, it isn't. So I like to test because sometimes you just kind of need to work things out, right? That's that engineering aspect. That's figuring out a problem and solving it, right? So let's see what happens if I type in 90. So this is going to tell it to stop, supposedly, or 1 second. And let's upload and see what happens. Ooh, this one does stop at 90. That's awesome. A lot of times I find it's not true 90. For some of these, it's 91 or it's 89, and you have to kind of give it a little bit of wiggle room, which just happens sometimes. Sometimes things need a little bit more room. So, perfect. Now that we know that one is exactly at stop at 90, let's see, what's a fun thing to do? We'll stop at 90 and then we'll go, let's do 89. So now it's going to stop and move really slowly. Ooh, so what it ended up doing was just stopping. So I guess it's seeing both 89 and 90 as stop. So now we've come up with a problem with our code, right? So our code isn't doing what we want it to do. So now we got to figure out how to make it do that, right? We were trying to go to the left because we went with 89 instead of 91, right? So let's try 88. So we're going to try and see if that will be what super slow-mo is for our servo. We're going to upload that again. And let's see what happens. Oh, it's going really slowly. I don't know if you can see. It's super, super slow. It doesn't even want to go. All right, let's see, 87. Let's see if it likes that one. And we're going to upload. Remember, anytime you change your code, you have to upload it again for it to catch that you've changed the code and receive that so it can change what it's doing, what the output is. If you just edit your code and don't ever upload it, it's not going to know that you changed it. It's going to keep going off the last code that it had. Oh, so we've got it moving a little bit more here. Just a little bit. It almost keeps going back. I don't know if you guys can see that. I'm nudging it a little bit because sometimes it's going so slow it's getting stuck, but that's mostly it just moving. Oh, this time it's stuck. Oh, there it goes. Just a little teak. All right, let's see. What about 80? Let's see what 80 itself does. We'll just get to the whole number. All right, 80. Remember, we always got to upload again. And let's see. There it goes. That's moving a lot more than it was before. Oh, it's still getting stuck. There we go. Yeah, that's a good turn, right? It's pretty slow. So you can actually program these servos to do a lot of really cool things. And you can program your LEDs to do a lot of really cool things. Arduinos have a lot of really fun functionality, a lot of really cool projects that you can do with them. Arduino as a software, it's a free available software and it does a lot, and there's a bunch of really cool projects. I really encourage, if you are interested in this and you want to try it out, go find yourself an Arduino, find yourself a circuit board. You can start programming some really fun things. I've actually worked with speakers before that you can program to do 8-bit songs with an Arduino. And that's really fun. Some people have some really cool stuff online, I gotta tell you, like Aha's Take on Me. Also, you know, the Star Wars theme, so well, the Imperial March, for those that know. But, so there's the Star Wars theme song that, you know, anytime Vader walks in a room. I've also found, I don't know if there's any old school game lovers out there, but Sonic the Hedgehog, someone did the theme song for the first game, which I really loved, so that was super cool for me. But there's a lot of really awesome functionality you can get out of these Arduinos, a lot of really fun projects to do. You know, this circuitry, this coding, it's a blast, really. It's a lot of fun. All right. So it's a little bit early, but I think I'm going to go ahead and call it there for today. Thank you so much for joining us. I hope you guys enjoyed this awesome little intro into what coding and engineering looks like in the Thinkabit lab at the Virginia Tech Roanoke Center. So thank you so much. I hope you guys have a great rest of your STEAM day.